In February 2025, a significant development in U.S. military aviation emerged from a relatively obscure division of the Defense Advanced Research Projects Agency DARPA. The Aerospace Projects Office (APO) unveiled plans for a large hypersonic bomber prototype, marking a pivotal shift in the U.S. military's approach to air superiority and combat capabilities. This initiative follows the ongoing Next Generation Air Dominance (NGAD) program, which has been focused on enhancing fighter aircraft capabilities. Background and context. The APO is known for its low profile even by DARPA standards, and its activities are not prominently featured on the agency's website. This secrecy underscores the strategic importance of the projects it undertakes. The decision to pursue a hypersonic bomber comes as potential adversaries, particularly in regions such as Asia and Europe, make significant advancements in hypersonic technology. The U.S. military recognizes the urgent need to maintain its technological edge in the air domain. The Hypersonic Bomber Project. The Hypersonic Bomber Initiative is predicated on the ability to travel at speeds exceeding Mach 5, which can provide the U.S. with a strategic advantage in both offensive and defensive operations. The project's design ethos is rooted in the need for speed, range, and stealth, allowing the aircraft to penetrate enemy defenses and deliver payloads with unprecedented speed. A key inspiration for this project is Lockheed Martin's State Route 72 concept, which features a turbine-based combined cycle propulsion system. This innovation is critical for achieving the hypersonic speeds required for modern combat scenarios. The State Route 72, often described as a successor to the State Route 71 Blackbird, has been lauded for its potential to operate at both subsonic and supersonic speeds, transitioning efficiently into hypersonic flight. Strategic implications. The development of a hypersonic bomber is not merely a technological endeavor, it is a response to evolving global threats and the need for deterrence. As adversaries develop their own hypersonic capabilities, the U.S. aims to ensure its military remains at the forefront of aerospace technology. The hypersonic bomber is seen as a necessary step to enhance the operational flexibility and reach of the U.S. Air Force. The urgency of this project is reflected in the timeline, which shows that the announcement of the hypersonic bomber follows years of work on the NGAD program. This indicates a deliberate transition from improving fighter capabilities to exploring broader applications in strategic bombers. Industry collaboration. The collaboration with industry leaders, particularly Lockheed Martin, highlights the importance of integrating advanced technologies into this new aircraft. Lockheed Martin's expertise in hypersonic systems and propulsion technology is expected to play a crucial role in the project. The integration of these capabilities is essential to meet the ambitious goals set forth by the APO. Conclusion. The Hypersonic Bomber Initiative represents a significant strategic pivot in U.S. military aviation. As global threats continue to evolve, the need for advanced capabilities becomes paramount. The successful development of a hypersonic bomber could redefine the air combat landscape, offering the U.S. military new ways to project power and deter adversaries. By investing in cutting-edge technology and fostering collaboration with leading aerospace companies, the U.S. aims to maintain its status as a global military leader in the face of emerging challenges. In summary, the emergence of the Hypersonic Bomber Project is a reflection of the changing dynamics of modern warfare, emphasizing the necessity for speed, stealth, and strategic reach in U.S. military aviation. As this project unfolds, it will be closely watched by military analysts and defense experts worldwide, given its potential implications for future conflicts and the balance of power in the air. The content presents several counterintuitive insights regarding the emerging hypersonic bomber project led by DARPA's Aerospace Projects Office (APO). Here are the key points. 1. Secrecy versus urgency. Typically, military advancements are accompanied by public discourse and visibility, however, the APO operates with notable secrecy. This contrasts sharply with the urgent need for hypersonic capabilities driven by advancements from potential adversaries. The expectation would be for such a critical project to be more publicized. Yet the opposite is true. 2. Transition from fighters to bombers. The strategic pivot from the Next Generation Air Dominance (NGAD) program focused on air superiority fighters to a hypersonic bomber project is unexpected. One might assume that air dominance would primarily revolve around fighter capabilities, but the emphasis on bombers indicates a broader understanding of future warfare where long-range strike capabilities may be prioritized over traditional dogfighting. 3. Collaboration with industry leaders. While one might expect a more insular approach to developing advanced military technology, the project highlights a collaboration with established defense contractors like Lockheed Martin. This partnership suggests a recognition that innovation in military technology relies heavily on private industry expertise, countering the notion that such developments must be entirely government-led. For a technological focus on propulsion systems, the emphasis on a turbine-based combined cycle propulsion system reflects a deeper reliance on advanced engineering that is not commonly associated with bomber designs. Traditionally, bombers are viewed through the lens of stealth and payload capacity, but this project's focus on achieving hypersonic speeds introduces a new dimension to bomber design philosophy. 5. Hypersonic technology as a deterrent. The project is positioned as a necessary response to perceived threats, which is not solely about offensive capabilities but also about deterrence. This counters the narrative that hypersonic advancements are only about achieving speed. They are also about strategic positioning and maintaining military supremacy in a rapidly evolving global landscape. 6. Low profile despite high stakes. The APO's low visibility amidst high-stakes technological advancements challenges the conventional expectation that significant military projects are accompanied by public relations campaigns and visibility. The choice to keep operations under wraps may reflect a strategic decision to minimize intelligence leakage and maintain a tactical advantage. 7. Broadening the definition of air superiority. The development of a hypersonic bomber could challenge traditional definitions of air superiority, which typically emphasize air-to-air combat. This suggests a paradigm shift in military strategy where long-range, high-speed bombers are seen as integral to maintaining air dominance. These counterintuitive points illustrate the complexities and strategic nuances involved in developing the hypersonic bomber project, revealing a multifaceted approach to modern military challenges. The report on the emergence of a hypersonic bomber prototype from DARPA's Aerospace Projects Office (APO) highlights several key aspects that, while discussed, may not receive the attention they deserve. Here are some important content elements that many may overlook, along with their significance. 1. DARPA's secrecy and low profile. The fact that the Aerospace Projects Office is not prominently featured on DARPA's website is significant. This reflects the sensitive and potentially groundbreaking nature of the projects it undertakes. The low visibility can be indicative of the advanced technologies being developed that may not yet be ready for public or competitor scrutiny. This secrecy suggests that the U.S. military is prioritizing the element of surprise and is aware of the competitive landscape in hypersonic technology. 2. Strategic pivot to hypersonic capabilities. The transition from the NGAD program to the hypersonic bomber indicates a strategic pivot in military aviation. While NGAD focuses on air dominance through advanced fighter capabilities, the hypersonic bomber represents a shift towards long-range strike capabilities. This pivot signifies an adaptation to evolving threats, where adversaries are developing similar or superior technologies. The urgency to develop hypersonic capabilities indicates a recognition of the potential for rapid conflict escalation and the need for the U.S. to maintain a technological edge. 3. Technological implications of the State Route 72 concept. The reference to Lockheed Martin's State Route 72 and its turbine-based combined cycle propulsion system is crucial. This technology could be a game-changer in achieving and sustaining hypersonic speeds, which are critical for the operational effectiveness of future bombers. The propulsion system's ability to operate efficiently at both subsonic and hypersonic speeds exemplifies the need for versatility in modern military aircraft. Understanding this propulsion technology's intricacies can provide insights into future air combat strategies and operational capabilities. 4. Potential adversaries' advancements. The report mentions the advancements in hypersonic technology by potential adversaries, which underscores a significant strategic concern. This dynamic highlights the arms race in hypersonic capabilities and the necessity for the U.S. to not only catch up but also lead in this domain. It raises questions about the broader implications for global security and the deterrence strategies that will need to evolve alongside these technologies. Ignoring the advancements of adversaries could lead to a critical miscalculation in defense planning. 5. Collaboration with industry leaders. The collaboration with Lockheed Martin emphasizes the importance of partnerships between government entities and private industry in advancing military technology. This relationship is significant because it showcases how innovation is often driven by synergistic efforts between defense contractors and government agencies. Moreover, it points to the reliance on private sector expertise to expedite the development of complex technologies, which is increasingly vital in a rapidly evolving military landscape. 6. Implications for future conflicts. The emergence of hypersonic bombers signifies a potential shift in how future conflicts may be conducted. With their ability to strike swiftly and from long distances, these aircraft could change the dynamics of air warfare, enabling rapid response to threats and enhancing deterrence. The operational flexibility that hypersonic bombers would offer could lead to new tactical doctrines and strategies which military planners must consider in their preparations for future engagements. 7. Broader military aviation strategy. The development of a hypersonic bomber is a reflection of a broader military aviation strategy that prioritizes speed, range, and survivability. This shift is significant in the context of modern warfare, where traditional air superiority is being challenged by emerging technologies and asymmetric threats. The capability to penetrate sophisticated enemy defenses with hypersonic bombers could redefine engagement rules and operational planning. 8. Timeline and program evolution. The timeline indicating that the hypersonic bomber project follows the NGAD program suggests a deliberate approach to military innovation. It illustrates how the U.S. is building upon existing programs to develop comprehensive capabilities that integrate advanced technologies. This methodical evolution is critical for ensuring that the military remains at the forefront of technological advancements and can respond effectively to changing warfare paradigms. In summary, the significance of the hypersonic bomber project extends beyond its immediate technological goals. It encapsulates a strategic response to global threats, a commitment to innovation through public-private partnerships, and a reimagining of military doctrine in the face of rapid technological change. Understanding these nuances is essential for grasping the full implications of this development for U.S. military capabilities and global security dynamics. 1. Strategic imperative of hypersonic technology. The emergence of the hypersonic bomber project highlights the U.S. military's urgent need to maintain air superiority in the face of rapidly advancing technologies from potential adversaries. The capability to operate at speeds exceeding Mach 5 offers significant tactical advantages, including reduced reaction times and the ability to penetrate advanced air defenses. This strategic pivot reflects a broader trend in military aviation towards developing technologies that ensure operational readiness and deterrence in an evolving global threat landscape. 2. Role of DARPA and the Aerospace Projects Office (APO). The secretive nature of the Aerospace Projects Office within DARPA is notable, as it operates under a low profile compared to other divisions. This discretion may be indicative of the sensitive nature of the hypersonic bomber project and the advanced technologies involved. The APO's focus on developing a large hypersonic bomber prototype signifies a critical shift from existing programs like the Next Generation Air Dominance (NGAD) towards broader applications in military aviation, underscoring DARPA's role as a catalyst for innovation within the U.S. defense ecosystem. 3. Integration of advanced propulsion technologies. The hypersonic bomber project is closely linked to advancements in propulsion systems, particularly the turbine-based combined cycle propulsion system proposed by Lockheed Martin for its State Route 72 concept. This technology is pivotal for achieving the high speeds necessary for hypersonic flight, enabling the U.S. military to capitalize on the operational benefits of such aircraft. The collaboration with industry leaders like Lockheed Martin illustrates the importance of public-private partnerships in fostering innovation and addressing the technical challenges associated with hypersonic flight. For transition from fighter to bomber capabilities, the announcement of the hypersonic bomber project marks a strategic transition from the NGAD program, which primarily focuses on next-generation fighter capabilities. This shift indicates a recognition of the need for a diverse range of aircraft that can fulfill various roles in modern warfare, including strategic bombing. The development of the hypersonic bomber prototype demonstrates a comprehensive approach to air power that incorporates both offensive and defensive capabilities, ensuring that the U.S. military can adapt to future conflict scenarios effectively. 1. The Manhattan Project 1942–1946. This was a research and development project during World War II that produced the first nuclear weapons. Led by the United States with the support of the United Kingdom and Canada, the Manhattan Project was a massive secret endeavor involving numerous scientists and engineers. Its success led to the development of atomic bombs that were dropped on Hiroshima and Nagasaki, ultimately contributing to the end of the war. The urgency and secrecy surrounding the project bear similarities to the current DARPA initiative, where advanced technologies are developed in response to perceived threats. 2. The Apollo Program 1961–1972. The Apollo program was a series of space missions aimed at landing humans on the Moon and safely returning them to Earth. Initiated by President John F. Kennedy, the program was a response to the space race during the Cold War, particularly following the Soviet Union's success with Sputnik. The program involved significant advancements in technology and engineering akin to DARPA's focus on hypersonic technology to maintain military superiority. The Apollo mission showcased the capability of a nation to achieve ambitious goals through innovation and collaboration. 3. The Strategic Defense Initiative 1983. Proposed by President Ronald Reagan, the Strategic Defense Initiative (SDI) aimed to develop a system to protect the United States from nuclear missile attacks through ground-based and space-based systems. The initiative focused on cutting-edge technologies including lasers and missile defense systems, similar to the hypersonic bomber project that seeks to leverage advanced propulsion systems for military applications. The SDI was characterized by its focus on maintaining military superiority during a time of heightened global tensions, reflecting the strategic importance of innovation in defense. The emergence of a hypersonic bomber project led by DARPA's Aerospace Projects Office (APO) marks a significant turning point in military aviation and U.S. defense strategy. As we look to the future, several key predictions can be made regarding the implications and developments surrounding this initiative. 1. Acceleration of hypersonic technology development. The urgency behind developing hypersonic capabilities indicates that the U.S. will likely allocate substantial resources and funding to research and development R&D. This project is anticipated to not only enhance the existing air dominance capabilities but also to foster advancements in propulsion technologies, materials science, and aerodynamic design. The collaboration with industry leaders like Lockheed Martin will spur innovation in turbine-based combined cycle propulsion systems, potentially leading to breakthroughs applicable beyond military contexts, such as commercial aviation and space exploration. 2. Shift in military strategy and doctrine. The strategic pivot to hypersonic bombers signifies a broader transformation in military doctrine. Future U.S. military strategies will increasingly incorporate hypersonic capabilities as a deterrent and operational tool. This means that conflicts may evolve into scenarios where speed and reach become paramount, allowing for rapid strikes against adversaries with less warning. The ability to deploy hypersonic bombers could reshape power dynamics, potentially discouraging aggression from rivals due to the fear of swift retaliation. 3. International arms race and hypersonic capabilities. As the U.S. advances its hypersonic bomber program, other nations will undoubtedly respond by accelerating their own hypersonic research and development efforts. Countries like China and Russia have already made significant strides in hypersonic technologies, and the U.S. move could trigger an arms race. The international security landscape may become increasingly complex, with nations vying to develop their own hypersonic platforms, leading to heightened tensions and an imperative for comprehensive arms control agreements. 4. Integration of AI and autonomous systems. The integration of artificial intelligence, AI, and autonomous systems into hypersonic bombers is likely to be a focal point of development. Future bombers may utilize AI for mission planning, threat assessment, and real-time decision-making, significantly enhancing operational effectiveness. This could lead to a new generation of combat aircraft capable of executing complex missions with minimal human intervention, raising ethical and operational questions about the role of AI in warfare. 5. Impact on existing military assets. The introduction of hypersonic bombers will prompt a reassessment of existing military assets and strategies. Older aircraft may be phased out or modified to integrate with hypersonic systems, while the capabilities of current fleets will be evaluated against the new benchmarks set by hypersonic technologies. This could lead to a more streamlined and technologically advanced military force capable of engaging in multi-domain operations that leverage the strengths of hypersonic platforms. 6. Cybersecurity and countermeasures. With the rise of hypersonic technologies, cybersecurity will become increasingly critical. Protecting hypersonic systems from cyber threats will be essential, as adversaries will likely seek ways to counter or disrupt these capabilities. Future defense strategies will need to incorporate robust cybersecurity measures alongside conventional military tactics. Additionally, counter-hypersonic technologies will emerge, focusing on intercepting or neutralizing hypersonic threats, leading to a perpetual cycle of technological advancement in defense systems. 7. Public and political perception of military expansion. As the U.S. pursues hypersonic capabilities, public and political perceptions of military expansion will play a crucial role. Increased investment in advanced military technologies may face scrutiny regarding budget allocation and ethical considerations surrounding warfare. Advocacy for transparency and responsible defense spending will become paramount in shaping the discourse on military expansion, particularly in the context of hypersonic capabilities. 8. Partnerships with allies and global collaboration. The development of hypersonic bombers may prompt the U.S. to strengthen its alliances and partnerships with other nations. Collaborative programs with allies could emerge, focusing on shared hypersonic technologies and joint operational capabilities. This approach may lead to enhanced interoperability and a unified response to global threats, reinforcing collective security arrangements. Conclusion. The hypersonic bomber initiative represents a significant leap into the future of military aviation and strategy. As the U.S. navigates this new frontier, the implications will reverberate across technology development, military doctrine, international relations, and public perception. The trajectory of hypersonic capabilities will be a defining feature of 21st century warfare, shaping both the defense landscape and geopolitical dynamics for years to come. The interplay of speed, technology, and strategy will redefine how nations engage in conflict and cooperation, making it imperative for stakeholders to adapt to this rapidly evolving environment.